we're going to graph this rational function, and to do that we'd like to know where the zeros are and the asymptotes and intercepts, that kind of thing. Well, the intercepts are the zeros, so and to do that we need to factor. So I suppose the first thing we could notice is right here we have the same degree top and bottom. So that means we take the ratio of the coefficients, which is 2 over 2 or 1. So first off, we know there's a horizontal asymptote at x equals 1. Okay, so not 0 like it would be if we had a smaller degree on the top. Since it's the same, we go to the coefficients and they tell us 2 over 2 is 1. So x equals 1. Okay, so the horizontal asymptote that's typical has been raised up. And now we're going to focus on factoring. So we can say, maybe you could just spot this, but if you say factors of 4, 2 times 2, that add up to 5, I think that's pretty clear what they are. They're 1 and 1 and 4, 1 and 5, 1 and 4. Okay, so how does that help me? The answer is I can rewrite the top as 2x squared, and I think 4 goes better with 2. I don't suppose it matters. So I'm going to say minus 4x minus 1x plus 2. And hopefully you can see that all I did was rewrite the middle term as 2 pieces. That's all I did, based on the first and the last. The first coefficient and the last constant. Okay, so can I get that out of there? Yeah, good. Okay. And then what I do is I factor something out of the first 2, and I factor something out of the last 2. Okay, if I can. So I say, well, it looks like a 2x would come out here, so that leaves x minus 2 behind in the first 2. These 2 right here. And then, I don't know how much I want to mark this up, but anyway, I'm going to just take out a negative 1. So negative 1, and that leaves x minus 2 behind. Okay, so now we see that for the top of my fraction, I'm going to have 2x minus 1. Okay, that's these leftover parts out here. Okay, and then obviously they both have x minus 2, so that's the other factor. Okay, so x minus 2. Alright, so I factored that. I call it the ACB method. I don't know. There's probably a better name for it. Now we're focused on the bottom here, and we're going to say 2 times 3. 2 times 3 is 6. Factors of 6 that add up to negative 7. So I should have said negative before, but anyway. Negative 6 and negative 1. Let me put negatives on there. Okay. So I do the same thing. I say 2x squared. I'll definitely put the 6 with the 2. Minus 6 minus x plus 3. So same thing happens. Instead of negative 7, I write negative 6 and negative 1. But it's the same. I just split it up. Okay, so these 2 right here, I'm going to say 2x comes out, and I get x minus 3 left behind. And then you can see I'll take out a negative 1 here, and I get x minus 3 left behind as well. So on the bottom, we're going to have, we get our 2x minus 1 again. Same thing. And down here I have x minus 3. Okay, so if I get the same thing on the top and the bottom, they will cancel. Okay, and that is a whole. Okay, if it would have been it would have been a vertical asymptote at x equals 1/2, because that would have made 0 on the bottom. But now it's not an asymptote because I cancel it out, and it's just a whole. Okay, the asymptote here comes in where x is equal to 3. There's the vertical asymptote. Vertical asymptote right there. Okay, so I guess I'll write that up here. The vertical asymptote is x equals 3, and the whole is at x equals 1/2. And what happens when I plug in 1/2? That's a great question. I'll just keep that in mind. Okay, so, because it really should be a point, but I'm going to get lazy for a minute. And where is my 0? Well, my 0's right here. This is a 0 when x is equal to 2. I get 0 on the top. Okay, so let's put this together. I'm going to say, here we go. I've got a horizontal asymptote at, I guess I'll keep the same color, at 1. Okay, and I know that there is a vertical asymptote at x equals 3, so 1, 2, 3. So there's my vertical asymptote. And we'll just write x equals 3 here. And x equals 1. Those are my asymptotes. And my hole is at 1/2, so I kind of want to keep that in mind. We could plug in something that was easy to get a bearing of where we are here. If we plugged in 0 for this, what would we get? F of 0, that would be very easy to plug in 0. We would get 2/3. Everything else disappears. So at 0, I'm at 2/3 right there. Is that 2/3? I guess. Looks more like half, but anyway, doing the best we can. And then I know there's a hole at 1/2, so I'm going to assume that's a little bit lower. I could plug in 1/2, but again, a little bit lazy. Okay, so this tells me that I'm down here. Okay, I could have been up here, but I'm not. I'm down below. Okay, because of the 0 point. And I can plug in more points, but I know I'm going to be hugging this line. So let me just go ahead and hug this line. I know I'm going through there. I know I'm going to go up to the hole and stop. And at somewhere I'm going to make a turn. And oh wait, where did I say I was going to make a turn? I said I was going to make a turn at x equals 2. All right there. That's the 0. That's another thing that tells me I'm down here instead of up there. And I make the turn, and I guess I would have liked to label that on the other side, but anyway. Does that look good enough? Maybe not. Anyway, it goes down there and it hugs that side. Now here's the thing. If I'm down here, okay, on the left side of the asymptote, then I'm going to come up here. I'm going to come up here and start on the other side and do, not an artist. I think it'd be easier if I drew it like this. Oh, that's not so great either. But anyway, the idea is that it hugs the asymptote down here, and it's also hugging the asymptote up here. The idea is we're in different places, top and bottom. So as we come in here, we're going up. So once we hit the asymptote, that means we have to switch down to this side on the other side. We have to switch down underneath the horizontal asymptote to continue on the other side. That's the typical thing. Okay, so that's enough detail right there. We have asymptotes, we have a hole, we have 0. I plugged in 0, but we really didn't need to. Oh, rats. We knew we were already down here in this, I hate to say quadrant, but here's a quadrant, here's a quadrant. These 4 quadrants are created by the asymptotes. So we were down here in this left to bottom quadrant, and which meant that we had to be up here for the other one. Okay.